All right, so next we're going to be using reference angles to evaluate trig functions. So find the missing side lengths of each of the following triangles. So I don't know if you guys remember this probably from your geometry class, but we have our special right triangles, which is our 45, 45, 90. And so on our 45, 45, 90, if that one's 1, then this side is also 1 because since these two angles are the same, these two sides are the same. Okay? So then we look for our hypotenuse. We look for this side. So there is a pattern, but I'm going to go ahead and just use Pythagorean Theorem real quick. So 1 squared plus 1 squared equals c squared. 1 plus 1 equals c squared. 1 plus 1 is 2, which is equal to c squared. Then we take the square root and we get the square root of 2 equals c. So that means that our hypotenuse here is the square root of 2. Okay. And then we have our next special right triangle, which is our 30, 60, 90. This one I'm probably going to have to use our special right triangles. But if this side is 1, then this side is 2, and this side is the square root of 3. So now from that information, let me go ahead and erase this so it doesn't look so messy. We're going to use our reference angles. So here it says express each of the following terms of a reference angle, then find the exact value of the trig ratio. So first we're going to go ahead and graph sine of 330 degrees. So this is going to be 90, this is 180, this is 270, and this is 360. So then that means 330 lands in the fourth quadrant. Okay, and I'm going to go ahead from here all the way to here is 330 degrees, but I'm going to make my triangle here. Okay, this is my angle theta. So if this whole angle here out here is 330 degrees, to find my reference angle, which is this angle in here, I'm going to do 360 minus 330. And that gives me 30 degrees. Okay, so my reference angle is in quadrant 4. It is 30 degrees. So then the sine of 330 degrees, the way that we're going to find that is we're going to copy this triangle. If you notice here, this one's our 30-degree angle, so across the 30 is 1, so I'm going to put a 1 here. This is my 60-degree angle, so across the 60 is the square root of 3. So that means that this one is the square root of 3. And then our hypotenuse is this side, the longest side, which is 2. In this case, this is my hypotenuse right here, which is 2. All right. So now we know that our sine is opposite over hypotenuse. Okay, so here my hypotenuse is 2, and my opposite is the 1. So sine of 330 degrees is 1/2. So you can do that without a calculator needed. If you wanted to check my work with the calculator, I'm just going to use the calculator we have on Delta Math. We have functions. We press sine of 330 degrees. We hit enter. It gives me negative 0.5. Oh, that's what I forgot, the negative. So, and that should have been on here somewhere. I should actually add it to sine. Okay, so remember how I showed you guys in the last lesson, that means all of our signs are positive in the first quadrant. Students, only sine is positive in the second quadrant, take. Only tangent is positive in the third, and then in the fourth quadrant, so all students take calculus. So only cosine is positive here. That means that our sine has to be negative. So I did forget that part, which is good that I double checked my work. All right, so the next one, cosine of 225. So first, 225, we figure out what quadrant it lands in. So here is 90, this is 180, this is 270. So that means that my triangle is going to be in the third quadrant. Okay, so I don't forget, I'm going to go ahead and do my all students take calculus right now. So all students take calculus. Since I'm in the third quadrant, only tangent is positive here. So that means that cosine is going to be negative. So I'm going to throw my negative in there so I don't forget it. So from here, all the way to here is 225 degrees. So we're going to find our reference angle, which would be this tiny little angle in our triangle. So we find that by taking the 180 and subtracting it from the 225. And that gives me 45 degrees. Okay, that means that I have this 45, 45, 90 triangle. So here's my 45, the one across my 45 is 1, the one across my other 45 is also 1, and the one across my 90 is the square root of 2. So 1, 1, and the square root of 2. Okay, my reference angle we found to be 45. Okay, so now let's go ahead and make our trig ratio. So cosine is adjacent over hypotenuse. In case you don't remember, we're using SOHCAHTOA. Okay, which cosine is adjacent over hypotenuse. My adjacent side, here's my angle. My adjacent side is this 1, so it'll be 1 over. My hypotenuse is the square root of 2. Remember, we're going to have to rationalize this, so we have to multiply the top and the bottom by the square root of 2. And this gives me the negative square root of 2 over 2. Alrighty. The next one. Okay, so this is why you can't always use a calculator, just putting it out there. But here, if we were to put cosine functions, cosine of, what was that? 225, sorry. 225 degrees. It gives me negative 0.707. So then I would have to put in the square root of 2 over 2. Should be our answer. See how it gave us 7.07 again. All right. So moving on to the next one. Now this one is in radians. I'm going to go ahead and change it just because I think it's a little bit easier to work with degrees. So 2 pi over 3, we're going to change it to degrees by multiplying times 180 over pi. So these cancel out, and then 2 times 180 is 360, divided by 3 is 120. All right, 1, 2, yeah. So 120 degrees is going to land in the second quadrant. So I make my triangle here. This is my 90-degree angle. From here to here is 120. This is the second quadrant. So to find the reference angle, this little angle in here, which is my angle theta, I have to do 180 minus 120, which gives me 60. Okay, so my reference angle is 60 degrees. Okay, so I'm going to go ahead and use my triangles that I have up here. So the one across my 60 here is the square root of 3. So I'm going to go ahead and put that in here. The one across my 60 is the square root of 3. So the side is square root of 3. And then the one across my hypotenuse is 2. And then the one across the 30-degree angle would be 1. Okay. So because we're looking for tangent, tangent is opposite over adjacent. So my opposite, the angle, is going to be the square root of 3. And my adjacent side is 1. So the square root of 3 divided by 1 is the square root of 3. And before I forget, I need to figure out what sign it is. So we do all students. That means that only sign is positive. So that means that since we have tangent here, it should be the negative square root of 3. All right, the next one. We have cosine of 7 pi over 6. So real quick, I'm going to change that 7 pi over 6 by multiplying times 180 over pi. Okay, this one's a little bit more complicated, so this one I do have to use my calculator. So 7 times 180 divided by 6. The pi's cancel out. This gives us 210 degrees. So we're looking at cosine of 210. Okay, so this is 90. This is 180. This is 270, and then this is 360. So that means that 210 is going to land in the third quadrant. Okay. That means from here to here is 210 degrees. So to find the reference angle, I'm going to go ahead and take the 210 and subtract this angle. So 210 minus 180 gives me 30. So that means this is 30 degrees. Okay, so real quick before I forget, because I always forget this part, all students take, that means only tangent is positive here. We have cosine, so that means it's going to be negative. And then let's go ahead and label our triangle. So across the 30, just in case you forget, across the 30-degree angle is 1. Okay, so here across the 30-degree angle, here is 1. This one is 2, and then this one's a square root of 3. Okay, so for cosine is adjacent over hypotenuse. Okay, so my adjacent side is going to be this side right here, to the square root of 3 over my hypotenuse 2. That's it. All right, we have 2 more of these. So next we have cotangent. So cotangent of negative 300 degrees. Okay, so negative 300, this will be negative 90. Oh. Negative 90, negative 180, negative 270, negative 360. So we happen to be in the first quadrant. This would be 300. Okay, so quadrant 1. Our reference angle, to find our reference angle, we're going to go ahead and take negative 300 and subtract a negative 360, which ends up turning to a positive. So that means our reference angle here is 60 degrees. So here's my triangle. This angle here is 60. The one across our 60 is the square root of 3. Our hypotenuse is 2, and the one across the 30-degree angle is 1. Okay. All of them are positive in the first quadrant. That means cotangent will be positive in the first quadrant. So I can leave it as a positive. And then cotangent is the opposite of tangent. So instead of being opposite over adjacent, it'll be adjacent over opposite. Okay. So this is my adjacent, and this is my opposite. So my adjacent is 1, my opposite is the square root of 3. And so we can't leave our answer like that. We do need to change it into radical form. Simplest radical form. So I do need to multiply the top and the bottom by the square root of 3, which gives me the square root of 3 over 9. Okay, the next one. We have secant of 315. So 315 would land in the fourth quadrant. So here's my triangle. So from here to here is 315, because this is 360. To find the reference angle, which is this angle right here, this is theta, we're going to go ahead and do 360 minus 315. That gives me 45. So 45 degrees, which means we have a 45, 45, 90, which means this side's 1, this side's 1, and this side is a square root of 2. Here we have secant, which is the opposite of cosine. So instead of being a over h, it's going to be h over a. All students take calculus, only cosine and its opposite are positive here. So that means this one's going to be positive. And then my hypotenuse is a square root of 2. My adjacent side is 1. This is hypotenuse, this is adjacent. So then just to simplify, it gives us the square root of 2. And that's it. We'll see you guys next time. Thank you. Bye.